Just imagine that you've got a leaky house. You're bringing in all of this polluted air, and more importantly, you're bringing in unwanted water vapor. The other issue with airtightness is you're also losing conditioned air. So it's very important to achieve airtightness. Okay, so passive house. I've been thinking about what distinguishes a passive house. In a lot of ways, a passive house is very similar to an Energy Star home or even to a Department of Energy zero energy ready home. It's energy efficient, it's durable, it's resilient, it's comfortable, it's healthy. But a passive house takes that all much further. And then it also adds two other elements. It adds a design certification process. So somebody is looking at our design and confirming that we're going to meet all their criteria. And then it also has heat recovery ventilation and balanced ventilation. And that's very heavily emphasized in a passive house. In order to achieve those goals of a passive house, we're going to have thermal control, we're going to have moisture control, we're going to have high performance windows, and then we're also going to have control of the air barrier. And so that's what we're talking about today, or air control essentially. Air control is kind of broken into what I think of as air sealing or air tightness, but then also ventilation and heat recovery. We'll talk about ventilation and heat recovery in another video. Essentially, we're focusing on air tightness today. And so air tightness is really important because it helps achieve energy efficiency, and it makes the house more durable, healthy, and comfortable. Just imagine that you've got a leaky house. You're bringing in all of this polluted air, and more importantly, you're bringing in unwanted water vapor. Water vapor comes into these leaks and reduces durability of the house, and it also promotes mold growth. So you're bringing in pollutants and you're bringing in vapor, water vapor. The other issue with air tightness is you're also losing conditioned air. So it's very important to achieve air tightness. We have a whole process that we go through to achieve an airtight building, and it starts with the sheathing. So we apply a product from Huber engineered woods called Zip R sheathing, and that sheathing incorporates the water resistive barrier and the air barrier along with a thermal component, and we can install that as one part. It replaces your house wrap essentially. Okay, we're outside the house here, and we're air sealing this house with our external sheathing. This Zip R system is going to provide air sealing, and then we've taped all the seams on the sheathing to make it airtight. But what we're also doing is any penetration through that envelope, we're sealing on the outside and the inside. So on the outside, we're sealing it with either tape, which we've done here on this sump pump penetration, or we're sealing it with liquid flash, which is what we've done here on the coolant line for the HVAC system. Typically, we try to penetrate the envelope with one hole per item, but that doesn't always work out, either because the subcontractors don't do it or it's just very inconvenient. So, like you can see here, this has been penetrated with 2 wires, and we've sealed that with both tape and liquid flash. The next step then for us is we seal the penetrations from the inside with spray foam. So we've taped them and liquid flashed them from the outside, and then we spray foam them from the inside. Then the next step for us is we put sheetrock on the ceiling. We mud and tape that, and that creates our air barrier on the ceiling. And then we have our insulation crew come, and they go up into the ceiling and they apply open cell spray foam on all of the top plates, both of the exterior walls, interior walls, from above. and that seals the ceiling. Any penetrations in that drywall, they will seal with open cell spray foam. Then they come down into the house, and they're going to seal the sill plates and any vertical structures that have a seam with a flexible caulk. So at that stage, we've got the house relatively tight. And our next step after that is Aerobarrier. So a typical home in Iowa, I don't know, I think code in Iowa might be, if you looked at how tight a house is, it'd be maybe 3 air exchanges an hour would be about what people are trying to achieve. And if we were building an Energy Star home, that number may be closer to 1.5. But for this house, with the certification we're trying to achieve, we have to get to 0.6 air changes per hour at 50 pascals. And the way that we're going to achieve that is we're going to seal it through all our standard methods, but then we're going to also do something called Aerobarrier, which is a byproduct of AeroSeal. And so I'm here with Dan Raleigh, and Dan is, we're actually right in the middle of doing this. So I'd like him to introduce himself, maybe tell us what the name of his company is, tell us what his experience is, and then maybe explain what's going on here.
Sure, yeah. So my name is Dan. Company is AeroSeal of Rochester. I've been doing duct sealing and envelope sealing, duct sealing for almost 13 years. The envelope sealing for 3 years now. And yeah, they kind of go hand in hand. Our duct sealing product and our envelope sealing product go hand in hand. And essentially all we're doing here is we're taking a glue product and pressurizing the house, and we're forcing that glue into any penetration that would be existing that we couldn't visibly see with our eyes. And so it allows us to economically get to these passive houses and not have to spend a whole bunch of time and extra labor to get to that point. It's a great product for these types of homes and what is trying to be achieved in this particular instance. So,
yeah, it's been fun watching it. I mean, it's kind of an interesting thing. We'll show some pictures of this later, but there's like these little robots almost out spread around the house that are aerosolizing this sealant. Mm-hmm. And then because we pressurize the house, now I know the ultimate test is at 50 pascals, but you're over pressurizing the house so that, you know, this sealant can find all these relatively invisible cracks and seams. And we tried pretty hard. I mean, we, you know, made some effort to seal the house anyway, and I forget what the initial test was, maybe 2.5.
It was around 2, and they did a great job. You know, this is when we're trying to achieve passive, this is where we want to start. This is a great point to start at. So this is awesome. We'll hopefully be done here within the next couple hours, and everything will be good to go.
Yeah, and we'll show this, but part of what's complicated the process is we still haven't been able to install our windows and doors.
Yep.
So we've kind of had to seal those, and we've got some leakage as a result of that, I think. But yeah, getting it 2, I think, is very acceptable on a normal home build, and we're just trying to get much better than that.
Absolutely, yeah. Absolutely.
Prior to Aerobarrier, the house had an air change rate, an hourly air change rate at 50 pascals of 2.1. And then after the Aerobarrier, we achieved 0.5. So our goal with Passive House, we have to reach 0.6 ACH50 or less. And so at this point we had that. Now we're at the next stage. So now what we've done is our insulation crew has come in and we've installed closed cell spray foam on all exterior walls. So here, this is actually on the foundation, and then it comes up over and onto the above grade wall. Below grade, this is 3.5 inches of foam, and above grade, 2.5 inches of foam. And this provides a near continuous air seal This product, I know there are lots of people that are worried about closed cell spray foam, but this product is made by Natural Therm, and it is a Owens Corning product now. It has a blowing agent that's low global warming potential, and it has low volatile organic compounds. We're in this house right now. It's been like a half an hour, 45 minutes since they stopped blowing, and I can barely even tell that there's any odor, and I suspect by this evening there'll be no odor in this house at all. It also is very helpful with thermal protection. So this product has a R value of over 7 per inch. So we're very happy with that. So we've finished this product. Now, after the Aerobarrier, then the next step will be, we'll put in our normal insulation, which is a net and blow fiberglass, and then we'll apply sheetrock to all of the walls, mud and tape that. That'll also be an air barrier. We normally would have installed our windows and doors, but the manufacturer has been holding those back from us. So ultimately, we're going to install high-performance windows and doors that will be airtight. At that point, because we did the Aerobarrier prior to window installation, we'll probably come back and repeat our blower door test after the windows and doors are in. And then if we have to, we can repeat Aerobarrier at that point. We don't want to wait to do Aerobarrier to the very end, because the prep and cleanup, if you've got your cabinets and your floors and all your other finishes in, it just makes it much more difficult.